April 8, 1943. 27,000 feet above France, the oxygen mask couldn't hide Oberleutnant Ralph Hermanson's smirk as he watched the ungainly silhouettes climbing laboriously toward his formation through the crystal-clear canopy of his Focke-Wulf 190A5. The veteran ace of Jagdgeschwader 26, aged 26, studied the American fighters making their combat debut over occupied Europe. "Their Air Force has sent us flying milk bottles," he transmitted to his wingman, unable to suppress his laughter at the sight of the massive Republic P-47 Thunderbolts struggling for altitude. Below them, 16 P-47C Thunderbolts of the 4th Fighter Group lumbered upward in tight formation, their 2,000 horsepower Pratt & Whitney R2800 double Wasp engines straining against their 7-ton weight. To German pilots accustomed to the sleek Spitfires and nimble Soviet fighters, these corpulent American machines appeared almost comical. Barrel-shaped fuselages topped with greenhouse canopies, wings that seemed too small for their massive bodies, propellers that dwarfed anything in the Luftwaffe inventory. What Hermanson didn't know, what none of the German pilots circling like wolves above could have imagined, was that they were witnessing the arrival of the weapon that would systematically destroy the Luftwaffe fighter arm. Within 18 months, these flying milk bottles would transform from objects of derision into instruments of terror, their .850 caliber Browning machine guns becoming the most feared sound in German skies. The mathematics of destruction were already loaded in those broad wings. 3,400 rounds of ammunition, a combined rate of fire of 6,000 rounds per minute, enough concentrated firepower to tear a Messerschmitt in half in less than 2 seconds. The transformation began that April morning when Major Donald Blakesley, commanding the 335th Fighter Squadron, spotted the German formation positioning for attack. The former Eagle Squadron veteran, who had transferred from RAF Spitfires just weeks earlier, understood what his men didn't yet know: that survival in the P-47 required abandoning everything they thought they knew about air combat. The Thunderbolt represented a radical departure from conventional fighter design philosophy. While the Germans had pursued lightweight interceptors optimized for climb and turn performance, Republic Aviation had created something unprecedented, a high-altitude juggernaut that used mass, power, and firepower to redefine the rules of aerial warfare. Among the 56 American pilots spread across the French sky that morning were men who would become legends, future aces whose names would strike fear into Luftwaffe hearts. But on April 8, 1943, they were novices in an untested machine, facing the most experienced fighter force in the world. The Germans had been fighting continuously since 1939 with veterans of Poland, France, Britain, and Russia. The Americans had been in combat for exactly 0 days. This story is about how industrial logic defeated tactical brilliance, how quantity and quality merged into overwhelming superiority, and how German pilots' laughter turned to terror as they discovered what synchronized Browning machine guns could do to an aircraft at 400 yards. The Republic P-47 Thunderbolt had emerged from a June 1940 panic. As German fighters swept across France, Alexander Kartveli, Republic Aviation's Georgian-born chief designer, received urgent specifications from the U.S. Army Air Corps. They wanted a high-altitude interceptor capable of matching the Luftwaffe's best. What Kartveli designed instead was a monster that redefined the possible. "It will be a dinosaur," Kartveli admitted to his design team, "but it will be a dinosaur with good proportions." The XP-47B prototype that first flew on May 6, 1941, shocked everyone who saw it. At 9,900 pounds empty, it weighed 65% more than its predecessor, the P-43 Lancer. The massive turbo supercharger system, with its complex ducting running through the rear fuselage, gave it an almost pregnant appearance. Test pilots approaching it for the first time invariably asked the same question: does this thing actually fly? Not only did it fly, it flew like nothing else at altitude. The Pratt & Whitney R2800 double Wasp engine, an 18-cylinder radial producing 2,000 horsepower, could maintain full power at 27,000 feet, where German fighters gasped for air. The turbo supercharger, fed by exhaust gases, delivered sea-level performance in the stratosphere, where the air was too thin for conventional superchargers. Major Hubert Hub Zemke, commanding the 56th Fighter Group, training at Bridgeport, Connecticut, initially despised the aircraft. His unit lost 18 pilots and 41 aircraft in training accidents between September 1942 and January 1943. The P-47 killed more Americans in training than Germans would in the first months of combat. It ground-looped on landing, torque-rolled on takeoff, and dove with such enthusiasm that pilots discovered compressibility, their controls freezing as shock waves formed on the wings. But those who mastered it discovered something extraordinary. Lieutenant Robert Johnson, a farm boy from Oklahoma, who would become one of America's top aces with 27 victories, described his first flight. It was like strapping yourself to a locomotive. The power was unbelievable. You didn't fly it, you aimed it. The first combat encounters in April and May 1943 confirmed every German prejudice. The P-47s couldn't turn with the Focke-Wulf 190s, couldn't climb with the Messerschmitt 10-9s, couldn't match their nimble handling at medium altitudes. Luftwaffe pilots quickly developed tactics to exploit these weaknesses, attacking from below where the heavy Thunderbolts struggled, forcing turning fights where agility mattered more than firepower. Hauptmann Josef Pips Priller, commanding officer of Jagdgeschwader 26, reported to headquarters after his first encounter. "The new American fighter is meat for the slaughter. It flies like a truck, turns like a freight train, and climbs like a pregnant cow. Our boys are calling them yabos, fat targets pretending to be warriors." The statistics seem to confirm German confidence. In their first month of operations, the American fighter groups lost 14 Thunderbolts for only 3 confirmed German kills. The RAF, observing from their Spitfire squadrons, quietly suggested the Americans might reconsider their choice of mount. British pilots joked that the best evasive maneuver in a P-47 was to unstrap and run around the roomy cockpit. But something strange was happening in those early encounters that German intelligence failed to notice. The P-47s that were shot down had absorbed incredible punishment before falling. One aircraft returned from a May 4th mission with 21 cannon holes and over 100 machine gun strikes, damage that would have disintegrated a Messerschmitt or Spitfire. The massive radial engine, lacking vulnerable coolant systems, shrugged off hits that would have stopped a liquid-cooled fighter cold. More significantly, when P-47s did get their guns on target, the results were catastrophic. The Thunderbolt's weapons battery created a convergence zone of destruction that German pilots had never experienced. Unlike the rifle-caliber weapons of early warfighters or the cannon with limited ammunition, the American fighter could maintain sustained fire for over 30 seconds, an eternity in aerial combat. The event that would begin changing German perceptions occurred on June 26, 1943, over Laval, France. It involved 2nd Lieutenant Robert S. Johnson of the 61st Fighter Squadron, and an encounter that would become legendary on both sides of the conflict. Johnson's formation of 48 P-47s was returning from escort duty when they were bounced by 16 Focke-Wulf 190s from Jagdgeschwader 26, led by Hauptmann Wilhelm Ferdinand Galland, younger brother of the famous Adolf Galland. The Germans executed a perfect attack, diving from the sun with overwhelming speed advantage. Johnson's Thunderbolt, flying at the rear of the formation, was caught in the crossfire of multiple attackers, taking catastrophic damage in the first seconds of combat. 20mm cannon shells exploded across his aircraft. The canopy shattered, hydraulic fluid sprayed into the cockpit, the engine cowling was torn away, and fire erupted behind the instrument panel. Johnson, wounded in the nose and leg by shrapnel and bullet fragments, tried to bail out, but discovered the canopy was jammed. A 20mm shell had exploded in the canopy track, welding it shut. He was trapped in a dying aircraft at 27,000 feet. What happened next defied every assumption about combat damage tolerance. Despite having no forward visibility through the oil-covered windscreen, a barely functioning engine that shook violently, and controls that responded only intermittently, Johnson managed to level the aircraft and point it toward England. The P-47 continued flying with damage that would have reduced any other fighter to falling debris. Then, it got worse. A lone Focke-Wulf 190, flown by an unknown pilot from Luftwaffe 26, discovered the crippled Thunderbolt limping toward the channel at less than 170 miles per hour. Historical research has never definitively identified this pilot, though several names have been proposed based on German combat reports from that day. What followed was one of the most extraordinary encounters in aerial warfare history. The German pilot positioned himself behind Johnson's P-47 and opened fire, with his 4 20mm cannon and 2 13mm machine guns. Johnson, unable to evade, could only huddle behind his armor plate and pray. The Thunderbolt absorbed the entire cannon ammunition load. Then the German repositioned and fired again, this time with only his machine guns. The cannon ammunition exhausted, the German pilot pulled alongside, staring in disbelief at the flying wreck. Johnson could see his face clearly, young, blonde, his expression shifting from confidence to confusion to something approaching fear. The German repositioned and emptied his remaining machine gun ammunition into the Thunderbolt. Still, it flew. He pulled alongside again, shook his head in apparent amazement, gave an informal salute, and peeled away, presumably out of ammunition. Johnson's P-47 landed at Manston with its engine failing on the runway. The crew chief stopped counting bullet holes after reaching 200. One cannon shell had exploded inches from Johnson's head. Another had detonated against the armor plate behind his seat. The engine had taken direct hits. The control cables were partially severed. 3 of the 4 main longerons, the structural backbone of the fuselage, were shot through, yet the aircraft had brought him home. The survival of Johnson's aircraft sent shockwaves through both air forces. American engineers studying the wreckage realized they had underestimated their own creation. German intelligence receiving combat reports from Luftwaffe 26 initially refused to believe it. No aircraft could absorb that much punishment. But testimony from multiple pilots confirmed the impossible. The Thunderbolt had taken everything the Luftwaffe's best fighter could deliver and survived. By July 1943, American pilots were learning to exploit the P-47's true strengths. Lieutenant Colonel Hubert Zemke, the 56th Fighter Group commander, had discovered the secret through brutal trial and error. Don't turn with them. Don't climb with them at low altitude. Use your weight. Use your power. Use your guns. The Thunderbolt's massive weight, initially seen as a disadvantage, became a weapon. In a dive, nothing could catch it. From 30,000 feet, a P-47 could reach 550 miles per hour, faster than any German fighter could achieve, even in a vertical dive. This speed could be converted into altitude in a zoom climb that left pursuing fighters helplessly behind. Captain Walker Bud Mahoran, who would become one of the first American aces in Europe, developed what became known as the boom and zoom tactic, though pilots called it the Thunderbolt turkey shoot. Instead of engaging in traditional dogfights, P-47 formations would climb to 30,000 feet, higher than German fighters could effectively operate. When Luftwaffe fighters appeared below, the Thunderbolts would roll inverted and dive, reaching speeds that made deflection shooting impossible for defending Germans. At the bottom of these dives, the American heavy machine guns would speak. German pilots who survived described it as facing a wall of lead, the combined firepower creating an impenetrable zone of destruction. Aircraft caught in this convergence pattern didn't just fall, they disintegrated. The true revelation of American firepower came during the August 17, 1943 duel raid on Schweinfurt and Regensburg, the deepest penetration into Germany attempted to that date. This mission would demonstrate both the P-47's limitations, its range, even with drop tanks, and its terrifying effectiveness when employed properly.
Major David Schilling, leading the 62nd Fighter Squadron, encountered a formation of Messerschmitt 110 destroyer aircraft, positioning to attack B-17s with their heavy cannon and rocket armament. The twin-engine German fighters, heavily armed but less maneuverable, were the Luftwaffe's specialized bomber killers. Schilling's flight of 4 Thunderbolts rolled into their attack dive from 28,000 feet. Unteroffizier Henrik Roth, a gunner in one of the Mi-110s who survived, later recounted in interrogation. The American fighters came down like hammers from heaven. I opened fire at 800 meters. Good hits. I saw them strike the fighter's wing. The P-47 didn't even wobble. Then he fired. The aircraft ahead of us simply came apart. Not shot down, destroyed. Wings separated from fuselage, tail severed, the crew compartment shredded into metal confetti. In 2 seconds, a Mi-110 became nothing. 8 Messerschmitt 110s were destroyed in less than a minute. The German pilots had never experienced such concentrated firepower. Each P-47 carried 425 rounds per gun, 3,400 rounds total, weighing nearly 900 pounds. At convergence distance, typically set at 300 yards, all 8 guns' ballistic paths intersected in a zone roughly 6 feet in diameter. Anything in that zone faced 100 half-inch projectiles per second, each traveling at 2,900 feet per second. The ammunition itself was a revelation of American industrial capacity. While German fighters struggled with limited cannon ammunition, typically 120 to 200 rounds for a 20mm weapon, American pilots could maintain fire for over half a minute. The standard combat load mixed armor-piercing incendiary tracer, and standard ball ammunition in patterns designed to both destroy and ignite. Lieutenant Colonel Francis Gabrski, who would become the top American ace in Europe with 28 victories, described the effect. When you hit them with all 8, they don't just go down, they explode. I saw a 109 literally cut in half, the nose falling one way, the wings and tail another. The pilot never knew what hit him.
By September 1943, the Luftwaffe was discovering another horrifying reality about the P-47. Its performance improved dramatically with altitude, while German fighters suffered. The turbo-supercharged double Wasp engine maintained its rated power output up to 30,000 feet. German fighters, relying on single-stage or two-stage mechanical superchargers, saw their performance degrade significantly above 25,000 feet. Oberleutnant Hans Philipp, one of Germany's most successful aces with 206 victories, encountered this reality fatally on October 8, 1943. Leading Jagdgeschwader 1 against a B-17 formation at 28,000 feet over Bremen, Philipp found his F-45 sluggish and unresponsive in the thin air. The BMW 801 engine, powerful at medium altitudes, was gasping for oxygen nearly 6 miles above the Earth. When P-47s of the 56th Fighter Group dove on his formation from 32,000 feet, the German fighters were sitting ducks. Robert Johnson, now an experienced combat pilot on his way to ace status, was flying at 31,000 feet when he spotted Philipp's distinctive Focke-Wulf with its elaborate nose art. Johnson's combat report was clinical. Opened fire at 300 yards, 30 degrees deflection. Observed strikes along entire fuselage. Enemy aircraft exploded. No parachute observed. Philipp's death sent shockwaves through the Luftwaffe. If one of their best, a man who had survived over 500 combat missions on both eastern and western fronts, couldn't survive against the Thunderbolts, what chance did average pilots have? The German High Command ordered an immediate investigation into the P-47's capabilities. The report delivered to Reichsmarschall Hermann Göring in November 1943 was sobering. The Thunderbolt's service ceiling exceeded 42,000 feet, higher than any German fighter could reach. Its dive speed approached the sound barrier. Its armor included a 3/8-inch steel plate behind the pilot, 1/2-inch bulletproof glass windscreen, and armored deflection plates around the engine. Most disturbingly, Its rugged construction allowed it to absorb damage that would destroy 3 conventional fighters and still return home. In January 1944, a new variant of the P-47 began arriving in England that would complete the transformation from laughingstock to nightmare. The P-47 D-22 featured a Hamilton Standard hydromatic propeller with paddle blades 13 feet in diameter, with broad chord blades that bit into the air like massive oars. The improvement in climb rate was immediate and dramatic. Where earlier Thunderbolts had climbed at an anemic 2,200 feet per minute at sea level, the paddle blade variants could achieve 3,000 feet per minute, matching or exceeding German fighters at most altitudes. The massive propeller also improved acceleration, allowing P-47s to build energy faster in level flight. Hauptmann Heinz Knoke of Jagdgeschwader 11, a veteran with over 200 combat missions, encountered the new variants in February 1944 during a bomber interception near Hanover. He wrote in his combat diary, "The fat American fighters have learned to climb. We bounced a formation near Hanover, expecting our usual advantage. They turned into us and climbed with us. When we tried to disengage, they followed us up to 30,000 feet. Schmidt was caught and blown apart, nothing left but smoke and fragments. These are not the same machines we laughed at last year." The paddle blade propeller did more than improve performance. It changed the sound of the Thunderbolt. The distinctive thundering roar created by the blade tips reaching supersonic speeds could be heard from miles away. German ground troops reported being able to identify approaching P-47s by sound alone, a deep, threatening rumble that meant death from above. They began calling it Donnerschlag, thunderclap. By March 1944, P-47s equipped with external fuel tanks could escort bombers deep into Germany. The standard configuration carried 2 108-gallon wing tanks, or a 75-gallon belly tank, extending range to over 1,000 miles. With the paddle blade propeller providing improved performance, even when loaded, Thunderbolts could fight on equal terms immediately after dropping tanks. The Luftwaffe's response was to concentrate on the bombers, hoping to inflict enough losses to stop the American daylight campaign. But this required flying through the P-47 escort screen, an increasingly suicidal proposition. German pilots developed a grudging respect that bordered on fear for the big American fighters. Major Günther Rall, one of Germany's top aces with 275 victories, mostly on the Eastern Front, survived an encounter with P-47s on March 6, 1944, that left him badly wounded. He later recalled in a post-war interview, "We saw them above us, fat silhouettes against the sun. Someone laughed and said, 'Here come the flying pigs.' Nobody was laughing 30 seconds later. They came down like an avalanche, faster than we could react. The first pass destroyed 3 of our fighters, just gone, transformed into burning debris. Their guns didn't fire in bursts like ours. They poured out solid streams of fire. Getting caught in that stream meant instant death." The escort missions revealed another P-47 advantage: endurance. While German fighters operated at maximum power settings that consumed fuel rapidly, the big American radials could cruise efficiently at high altitude. Thunderbolts could remain with the bombers for hours, rotating top cover while maintaining enough fuel for combat and return. As more P-51 Mustangs arrived to take over long-range escort duties in spring 1944, P-47 units increasingly focused on ground attack, a role that would make them the most feared aircraft in the German arsenal. The transition began in earnest in April 1944 as the Allies prepared for the invasion of France. The Thunderbolt's heavy machine gun battery proved equally effective against ground targets. The standard armor-piercing incendiary ammunition could penetrate the top armor of most German vehicles, while the sheer volume of fire could destroy soft targets in seconds. A 2-second burst put 160 half-inch projectiles into a target area the size of a truck.
But it was the addition of bombs and rockets that transformed the P-47 into a true multi-role monster. The D-25 variant could carry two 1,000-pound bombs under the wings and a 500-pounder under the fuselage, a bomb load equal to early war medium bombers. Later variants added zero-length rocket stubs for 10 5-inch high-velocity aircraft rockets, HVARs, each equivalent to a 105mm artillery shell. Oberst Hans von Luck, commanding the 125th Panzer Grenadier Regiment during the Normandy campaign, experienced P-47 ground attacks firsthand. They came in low, so low you could see the pilots' faces. The sound was terrifying. Engines roaring, rockets screaming. Then the hammer of those heavy machine guns. A column of our trucks simply ceased to exist. 20 vehicles transformed into burning wreckage in one pass. The psychological effect on the men was devastating. They called them Jabos, fighter bombers, but these were something beyond that. They were flying artillery with the accuracy of snipers.
On June 6, 1944, the Luftwaffe discovered how completely the balance of power had shifted. Over 500 P-47s provided air cover for the invasion, creating an impenetrable umbrella over the beaches. German fighters attempting to reach the landing zones were massacred. Oberleutnant Wolfgang Fischer of Jagdgeschwader II, one of only 3 German pilots to reach the beaches that day, reported, "The sky belonged to the Americans. Thunderbolts were stacked from sea level to 30,000 feet. We tried to break through at dawn. 12 fighters from our group. I was the only one to return. The P-47s were waiting at every altitude. You couldn't climb over them, couldn't dive under them. Their guns turned our fighters into aluminum rain." In the weeks following D-Day, P-47s systematically destroyed German movement in daylight. The statistics were staggering. In June alone, 9th Air Force Thunderbolts claimed 651 locomotives, 3,847 trucks, 512 tanks and armored vehicles, and 4,553 horse-drawn vehicles destroyed. The Wehrmacht was forced to move only at night, severely hampering their ability to respond to Allied advances. The Germans tried everything to counter the Thunderbolt threat. They reinforced vehicle armor, deployed more anti-aircraft guns, developed new camouflage techniques. Nothing worked. The P-47's combination of speed, armor, and firepower made them nearly unstoppable. Even the feared 88mm flak guns struggled to track the fast-moving fighters at low altitude. While devastating Europe, the P-47 was simultaneously proving its worth in the Pacific theater. The 348th Fighter Group operating from New Guinea discovered that the Thunderbolt's qualities were perfectly suited to the vast distances and harsh conditions of the Pacific War. Colonel Neil Kirby, commanding the 348th, developed tactics specifically for the Pacific. On October 11, 1943, Kirby led 4 P-47s against 40 Japanese aircraft over Wewak, shooting down 6 enemy planes himself in a single mission, earning him the Medal of Honor. The Japanese, accustomed to fighting nimble but fragile American fighters, were unprepared for the P-47's combination of firepower and durability. Japanese ace Saburo Sakai, who encountered P-47s over New Guinea, later wrote, "We called them monsters. Our 20mm cannon, which could destroy a P-40 with a few hits, seemed to have no effect. I put dozens of rounds into one Thunderbolt and watched it fly away. Their return fire was terrifying, streams of heavy bullets that tore aircraft apart." The P-47N, developed specifically for the Pacific, featured increased fuel capacity with wet wings holding 93 gallons each, extending range to 2,350 miles. This variant would escort B-29s to Japan, proving that the short-legged fighter of 1943 had evolved into a true long-range weapon. Perhaps the ultimate vindication of the P-47's evolution came in its encounters with German jet fighters.
The Messerschmitt Me-262, with its 540-mile-per-hour top speed, should have been untouchable by propeller-driven fighters. But P-47 pilots discovered they could catch jets in two situations: during takeoff and landing, when jets were most vulnerable, and in high-speed dives from altitude. On November 27, 1944, Lieutenant Colonel John C. Meyer of the 352nd Fighter Group became one of the first pilots to shoot down an Me-262 with a P-47. Diving from 28,000 feet, Meyer's Thunderbolt reached speeds approaching 500 miles per hour, fast enough to catch the jet in level flight. The jet pilot, confident in his speed advantage, never saw the diving P-47 until Meyer's guns opened up at 400 yards. Meyer's combat report noted, "The enemy aircraft disintegrated under fire. Large pieces, including both engines, separated from the fuselage. The pilot did not escape." The concentrated fire of 8.5 caliber guns proved more effective than we anticipated against jet aircraft. By early 1945, specialized P-47M variants were deployed specifically to counter German jets and V-1 flying bombs. With water methanol injection boosting power to 2,800 horsepower and refined aerodynamics, these ultimate Thunderbolts could reach 470 miles per hour in level flight at 30,000 feet, fast enough to intercept even jets under certain conditions. Major George Boswick, commanding the 63rd Fighter Squadron equipped with P-47Ms, shot down two Me-262s in March 1945. His tactical report emphasized firepower over speed. "The jets are faster, but they can't turn and they can't take punishment. One good burst from our battery and they come apart like they're made of paper. They have to slow down to attack bombers. That's when we get them." The ultimate demonstration of American industrial might came during Operation Bodenplatte, the Luftwaffe's desperate attempt to destroy Allied air power on January 1, 1945. Nearly 900 German fighters, including their best remaining pilots, launched surprise attacks on Allied airfields across Belgium and the Netherlands. At Ash Airfield Y-29, home to the 366th Fighter Group's P-47s, the attack initially succeeded. German fighters destroyed several P-47s on the ground, along with other aircraft. A captured German pilot brought to the command post pointed at the burning aircraft and taunted, "What do you think of that?" Major George Bostwick's response became legendary throughout the 9th Air Force. "By tomorrow, we'll have 30 new ones. How long will it take you to replace your pilots?" The German pilot's smirk disappeared. Within 48 hours, factory-fresh P-47 D-40s filled the flight line, flown in from depots in England. The Luftwaffe lost 271 aircraft and 213 pilots in Bodenplatte, including many irreplaceable instructors and squadron leaders. These losses they could never replace. The Americans lost 134 aircraft total across all attacked airfields, all replaced within a week. The numbers told the story of inevitable defeat. Republic Aviation produced 15,684 P-47s during the war, more than any other American fighter. At peak production, the Farmingdale factory on Long Island completed one Thunderbolt every hour around the clock. The Evansville plant in Indiana, built from empty farmland in 1942, was producing 500 aircraft per month by 1944. Each P-47D required 65,000 individual parts, 8 miles of electrical wiring, 2,000 pounds of aluminum, and 300 pounds of rubber. The engine alone contained 2,400 individual components machined to tolerances of thousandths of an inch. Yet American workers, many of them women who had never seen an aircraft before Pearl Harbor, assembled these complex machines with precision that exceeded peacetime standards. The ammunition production was equally staggering. Each P-47 sortie required 3,400 rounds of 50 caliber ammunition, with hundreds of Thunderbolts flying daily missions. Ammunition consumption exceeded 10 million rounds per month by mid-1944. The Lake City Arsenal in Missouri, one of several ammunition plants, produced 30 million rounds monthly. Each cartridge was manufactured to tolerances measured in 10,000ths of an inch, ensuring reliable feeding through the synchronized gun mechanisms. The fuel consumption was enormous. Each Thunderbolt burned 100 gallons per hour in normal flight, up to 300 gallons in combat with water injection engaged. The 9th Air Force alone consumed over 25 million gallons of aviation fuel by late 1944, all of it shipped across the Atlantic in tankers that were themselves products of mass production.
Even more impressive than aircraft production was pilot training. By 1944, the United States was graduating 30,000 pilots annually from advanced training, more than Germany had trained in the entire war. Each P-47 pilot received a minimum of 400 hours of flight training before entering combat, including 100 hours in advanced fighters. German pilots, by contrast, were entering combat with less than 100 hours total time by war's end. The quality showed in combat. American pilots arrived in Europe trained in formation flying, instrument navigation, gunnery, and tactics. They had practiced against captured German aircraft, understanding their enemy's capabilities and limitations. They knew their aircraft systems intimately, having studied technical manuals that German pilots never received. Lieutenant Eugene Roberts, arriving in England in September 1944, exemplified the American training advantage. I had 420 hours in my logbook, including 75 hours in the P-47. I'd fired at towed targets, practiced deflection shooting, studied gun camera film from actual combat. My first mission, I knew exactly what to do. The German pilot I faced couldn't have had half my experience. It wasn't even a fair fight. In March 1945, Hauptmann Josef Priller, the same pilot who had mocked the P-47s as pregnant cows 2 years earlier, was interviewed by German propaganda officials seeking to boost morale. His statement, deemed too demoralizing for publication, revealed the complete transformation in German attitudes. The Thunderbolt is the best fighter bomber ever built. Its firepower is unprecedented. Weapons that never jam, never overheat, never run out of ammunition in normal combat. It carries bombs like a medium bomber, fires rockets like artillery, and fights like a fighter when needed. But beyond the machine is what it represents: unlimited American production. They lose 10, they build 20. We lose 1, it's gone forever. Their pilots arrive better trained than our instructors. They have fuel for training, ammunition for practice, spare parts for everything. We have nothing but courage. And courage without resources is just delayed defeat. We laughed at them in 1943. We're not laughing now. When you hear those guns, you know death has come calling. The sound haunts us. Mechanical, precise, unstoppable. Like everything American, it's about overwhelming material superiority. They didn't beat us through better tactics or braver pilots. They buried us under an avalanche of steel and lead. By April 1945, the Luftwaffe existed largely on paper. Fuel shortages grounded most aircraft. Experienced pilots were dead or captured. Airfields were cratered ruins. But even with aircraft and fuel, German pilots faced an impossible equation. Attacking meant facing P-47 formations that owned every altitude from ground level to 40,000 feet. Feldwebel Klaus Brechner, one of the last German pilots trained in 1945, flew exactly one combat mission before the war ended. His encounter with P-47s over Leipzig lasted 12 seconds. I saw them diving from above, 4 Thunderbolts in perfect formation. I tried to turn, but they were too fast. The leader fired from 500 meters. My aircraft shook like it was hit by sledgehammers. The engine exploded, the wing separated. I barely escaped. In the parachute, I watched them destroy my entire Staffel, 6 fighters gone in under a minute. The sky rained burning aluminum and bodies. The psychological impact was complete. German pilots developed what medical officers called Yabo fever, physical symptoms of stress appearing when Thunderbolts were reported in the area.
Veterans who had faced Spitfires and Hurricanes without fear became physically ill before missions against P-47s. The distinctive thunder of approaching Thunderbolts caused panic among ground troops who knew that survival meant finding cover immediately. The final statistics of P-47 operations defied comprehension. In Europe, 3,752 German aircraft destroyed in aerial combat, 3,315 aircraft destroyed on the ground, 86,000 railway cars destroyed, 9,000 locomotives destroyed, 60,000 armored fighting vehicles destroyed, 60,000 horse-drawn vehicles destroyed. In the Pacific, 697 Japanese aircraft destroyed in aerial combat, 150 aircraft destroyed on the ground, 1,500 vehicles destroyed, 150 locomotives destroyed, countless barges, ships, and installations. The 9th Air Force alone, primarily equipped with P-47s, flew 213,873 combat sorties, dropped 120,000 tons of bombs, fired 135 million rounds of ammunition, and launched 60,000 rockets. The Thunderbolt units achieved a 4.6 to 1 kill ratio in aerial combat, while maintaining the lowest loss rate of any Allied fighter-bomber. Behind these numbers lay the human cost. The Luftwaffe lost approximately 28,000 pilots killed in combat against Western Allied forces. Many fell to the concentrated fire of American heavy machine guns. Each loss represented years of training that Germany could never replace. By war's end, the average German fighter pilot had less than 30 hours of combat experience. The average P-47 pilot, over 200. At the Luftwaffe Interrogation Center at Oberrussel, captured Allied pilots were debriefed by German intelligence. The records captured in 1945 revealed German assessments of Allied aircraft. The file on the P-47, updated continuously throughout the war, showed the complete reversal of opinion. April 1943. Large, unmaneuverable fighter. Inferior to German types in all performance parameters except dive speed. Machine gun armament insufficient against cannon-armed fighters. Assessment: minimal threat. December 1943. Exceptional high-altitude performance. Extreme structural strength. Firepower increasingly problematic. Pilots showing improved tactics. Assessment: significant threat above 25,000 feet. June 1944. Dominant fighter bomber. Superior to all German types above 20,000 feet. Firepower devastating against all target types. Structural strength makes shoot-down extremely difficult. Assessment: critical threat at all altitudes. March 1945. Best fighter bomber of the war. Combination of firepower, durability, and performance unmatched. Pilot quality exceptional. Assessment: unsurvivable in direct engagement. In 1985, at a reunion of German and American fighter pilots in Phoenix, Arizona, former adversaries met in peace. General Adolf Galland, former head of the Luftwaffe fighter arm, was asked about the P-47. His response, recorded on video, captured the complete transformation in opinion. "We made a terrible mistake in 1943. We saw this big, heavy fighter and laughed. The Americans don't understand air combat. They built a bomber and called it a fighter. We were the ones who didn't understand. The Americans didn't try to build a European fighter. They built an American one designed around production, firepower, and survivability. They understood that in the war of attrition, the plane that could take punishment and deliver devastating firepower would win. They were right. The first time I flew a captured P-47 after the war, I understood everything. The power was incredible. It climbed like it was falling upward. The cockpit was comfortable. The visibility excellent. The controls precise. It was a pilot's aircraft wrapped in armor. But what really impressed me was realizing that America built over 15,000 of these complex machines while fighting a two-ocean war. Each one required an engine more complex than anything Germany produced. Yet they built them faster than we could build simple fighters. That's when I knew we never had a chance. Those guns, we called them Roosevelt's piano because of the sound they made. Once you heard that sound, you never forgot it. Many of my friends heard it for the last time. The P-47 didn't just defeat the Luftwaffe, it destroyed it. The P-47's design represented American industrial philosophy perfectly. Brute force engineering backed by unlimited resources. Every component was overbuilt, overpowered, and over-engineered. The wing spars could support 40,000 pounds, 3 times the aircraft's loaded weight. The engine mount could withstand 12 G-forces. The control cables were doubled throughout with automatic backup systems. The ammunition feed system alone was a marvel of engineering. 8 separate ammunition boxes, each holding 425 rounds, fed through electric boost motors to prevent jamming during high-G maneuvers. The guns were electrically heated to prevent freezing at altitude. Each gun had its own charging mechanism and could be individually synchronized. The convergence was adjustable from 150 to 400 yards, allowing pilots to optimize for their preferred engagement range. Even after the war, some German veterans maintained that the P-47 won through quantity, not quality. That German fighters were technically superior but overwhelmed by numbers. The combat records tell a different story. In engagements where numbers were equal,
The P-47's impact on German morale extended far beyond the cockpit. Ground troops developed an almost superstitious dread of the aircraft they called Jabos, a shortening of Jagdbomber, or fighter bomber. The psychological warfare effect was immense. Veteran German infantryman Erich Mende, who survived the Normandy campaign, later recalled, "The sound of those engines was unlike anything else, deep, thunderous, shaking the very ground. When we heard that sound, we knew death was coming." The P-47s didn't just attack, they obliterated. A single pass could destroy an entire column. We learned to recognize their silhouette instantly, that massive elliptical wing, the huge propeller, the distinctive cowling. They flew so low we could see the pilots' faces, and they never seemed to run out of ammunition. Their 50 caliber guns made a sound like tearing canvas, but magnified 1,000 times. When those guns fired, everything in their path was destroyed. We had excellent anti-aircraft units, but the Thunderbolts flew through flak that would have shredded any other aircraft. I saw one take multiple direct hits from 20mm flak and keep flying as if nothing had happened. After Normandy, the mere sound of approaching Thunderbolts would send experienced soldiers diving for cover. It wasn't cowardice, it was survival instinct. We saw what they could do. The P-47's reputation grew with each successful mission. By late 1944, German tank crews had developed specific procedures for when Thunderbolts appeared. Panther tank commander Otto Carius wrote in his memoirs, "The American Jabos were our greatest fear. Their rockets could penetrate our side and rear armor, and their machine guns could disable our tracks and vision blocks in seconds. We learned to immediately deploy smoke and seek cover under trees or buildings when we heard their distinctive engine sound. Unlike the British Typhoons, which typically attacked from higher altitudes, the P-47s would come in at treetop level, giving us almost no warning. Their accuracy was terrifying. I saw one Thunderbolt destroy 3 armored cars with a single pass, each hit dead center. We began painting large crosses on our turret tops, hoping they would recognize us as German and break off their attacks, but it rarely worked. The P-47 pilots were relentless." The effect on German logistics was equally devastating. Supply columns could only move at night, and even then they weren't safe from prowling Thunderbolts. The 9th Air Force developed night intrusion tactics, where P-47s, equipped with rudimentary navigation aids, would hunt German transport along known routes. While not as effective as daytime operations, these night missions further demoralized German supply troops and reduced the flow of essential materials to the front. The psychological impact reached its peak during the Battle of the Bulge. As German forces pushed through the Ardennes, P-47s operated in weather conditions that grounded other aircraft. Their rugged construction and pilot training allowed them to fly in conditions that German pilots considered impossible. When the weather finally cleared on December 23, 1944,
Hundreds of Thunderbolts fell upon the exposed German columns. The results were catastrophic for the German offensive. Panzer crewman Hans Heckmann described the scene. For 3 days we had advanced almost unopposed from the air. Then the skies cleared and the Jabos came. It was like the gates of hell opening. They came in waves, one after another, bombing and strafing everything that moved. Our fuel trucks exploded, ammunition carriers disappeared in fireballs, tanks sat burning by the roadside. In 1 hour, our battalion lost 30 vehicles. We tried to fight back with our machine guns, but the P-47s just absorbed the fire and kept coming. They seemed invincible. That day broke the spirit of our offensive. We knew that we couldn't win. The P-47's versatility made it particularly feared. Unlike specialized aircraft that excelled in one role but were mediocre in others, the Thunderbolt proved outstanding in multiple missions. It could engage enemy fighters at high altitude, then descend to treetop level to destroy ground targets, all on the same sortie. This multi-role capability meant German forces never knew what to expect when Thunderbolts appeared. They might be there to provide top cover for bombers, or they might be hunting tanks, or they might be specifically looking to engage Luftwaffe fighters. This uncertainty created constant tension among German units. The aircraft's reputation even affected German civilian morale. In areas subject to regular P-47 operations, workers became reluctant to travel during daylight hours. Factory production suffered as workers spent excessive time in air raid shelters. While the strategic bombing campaign targeted industrial centers, the P-47's constant presence over transportation routes and battlefield areas created a pervasive sense of vulnerability that undermined the German war effort at every level. The psychological impact was perhaps best summarized by General Feldmarschall Albert Kesselring, who commanded German forces in Italy. The P-47 was not merely an aircraft, it was a psychological weapon of the first order. Its appearance alone could disrupt operations. Its sound created panic. Its durability seemed supernatural. Our pilots feared it, our soldiers dreaded it, and our civilian population saw it as an instrument of inevitable defeat. No other Allied aircraft had such a comprehensive demoralizing effect. This fear was compounded by the P-47's unmistakable appearance and sound. Unlike the sleeker P-51 Mustang or the more conventional-looking Spitfire, the P-47's massive size and distinctive engine note made it instantly recognizable. German spotter guides specifically highlighted the P-47's unique features: the large elliptical wings, the deep fuselage, the characteristic turbo-supercharger exhaust, and the four-bladed propeller that created a distinctive beating sound in the air. Ground observers were trained to immediately report P-47 sightings using specific code words, so valuable was early warning against these aircraft. The legend of the Thunderbolt's invincibility grew with each returning aircraft that should have been lost. Stories circulated through German units of P-47s returning to base with hundreds of holes, missing sections of wing, with oil-covered windscreens, even with parts of their tails shot away. While some of these accounts were exaggerated, enough truth existed to sustain the mythos. The aircraft's robust construction and redundant systems meant that damage that would destroy other fighters often proved survivable in the Thunderbolt. This reputation for indestructibility had a tangible effect on combat outcomes. German pilots, believing they needed perfect shots to bring down a Thunderbolt, often hesitated or broke off attacks. Ground gunners, seeing their fire apparently having little effect, sometimes lost heart and ceased firing. The psychological advantage created by the P-47's reputation arguably saved countless American pilots and aircraft. By war's end, the mere appearance of Thunderbolts could determine the outcome of ground engagements. German units would often cease movement and seek cover when P-47s were reported in the area, even if the aircraft were miles away and engaged in other missions. This shadow effect multiplied the P-47's actual combat power, allowing relatively small numbers of aircraft to influence large sections of the battlefield through reputation alone. The ultimate testament to the P-47's psychological impact came in post-war interviews with German commanders. When asked what single weapon most concerned them, many cited the P-47 ahead of more famous weapons like the Sherman tank or the B-17. They recognized that while other weapons caused physical destruction, the P-47 created a climate of fear that affected decision-making at every level, from the high command to the individual soldier.
This psychological dimension, combined with its physical capabilities, made the Thunderbolt one of the most effective weapons of the Second World War.
The technical evolution of the P-47 throughout the war demonstrated American industrial adaptability at its finest. From the initial P-47B with its teething problems to the ultimate P-47N long-range escort variant, the aircraft underwent continuous improvement based on combat experience. Each modification addressed specific shortcomings while enhancing the aircraft's inherent strengths. The P-47C introduced a longer fuselage to improve stability and added attachment points for external fuel tanks, extending the aircraft's limited range. The P-47D, the most produced variant, featured a more powerful R-2859 engine with water injection, providing emergency power for combat situations. The bubble canopy, introduced on later P-47D models, dramatically improved rearward visibility, addressing one of the few genuine weaknesses in the original design. This modification came directly from pilot feedback and gave Thunderbolt pilots better situational awareness in dogfights. The P-47M represented the ultimate expression of the Thunderbolt as a pure fighter. With its specially modified R-2857 engine producing 2,800 horsepower and refined aerodynamics, it could reach 473 miles per hour at 32,000 feet, performance that rivaled even the P-51 Mustang. Only 130 P-47Ms were built, and they were primarily used to counter the V-1 flying bomb threat and the Me-262 jets. The P-47N, designed for the Pacific theater, featured wings extended by 18 inches to accommodate additional fuel tanks, giving it a range of over 2,000 miles. This allowed it to escort B-29s on their long missions to Japan. The N model also incorporated all the lessons learned in the European theater, including the bubble canopy, additional armor protection, and upgraded weapons systems. What made the Thunderbolt's evolution remarkable was the speed with which improvements were implemented. The American industrial system could incorporate combat feedback into production aircraft within months, sometimes weeks. When pilots reported difficulty with the original framed canopy, Republic Aviation developed the bubble canopy and had it in production within 6 months. When range limitations became apparent, engineers designed and tested drop tank systems that were soon standard on all production aircraft. This rapid iteration cycle meant that German pilots often faced significantly improved Thunderbolts within the same combat tour. A pilot who had fought P-47Ds in early 1944 would encounter much more capable aircraft if he returned to combat in late 1944. This constant improvement kept the Thunderbolt competitive throughout the war, even as German aircraft technology advanced with types like the FW-190D and TAL-152. The manufacturing process itself was a masterpiece of industrial engineering. Republic Aviation employed innovative production techniques that allowed them to build complex aircraft at unprecedented rates while maintaining quality. The Farmingdale factory used assembly lines similar to automobile plants, with aircraft moving through successive stations where specialized teams installed specific components. This division of labor allowed workers to become highly proficient at their tasks, reducing errors and increasing production speed. Quality control was maintained through rigorous inspection at every stage of production. Each major component was tested before installation, and completed aircraft underwent extensive flight testing before delivery. Despite the pressure of wartime production, Republic maintained standards that resulted in aircraft renowned for their reliability and consistent performance. The Evansville, Indiana plant represented an even greater achievement. Built from scratch in 1942 on what had been farmland, it was producing 500 P-47s per month by 1944. The creation of this facility demonstrated American industrial capacity at its most impressive, not merely increasing production at existing facilities, but creating entirely new manufacturing complexes where none had existed before. The logistics supporting P-47 operations were equally impressive. Maintaining hundreds of aircraft in combat required a massive support infrastructure. Spare parts had to be manufactured and shipped across the Atlantic. Maintenance crews had to be trained to service the complex turbo-supercharger systems and powerful engines. Armorers needed to manage the enormous quantities of ammunition required for the 8.50 caliber guns.
The U.S. Army Air Forces developed sophisticated supply chains that kept Thunderbolt units operational despite the demands of continuous combat. Damaged aircraft were rapidly repaired using parts cannibalized from written-off planes or supplied from rear area depots. The ability to return damaged aircraft quickly to service multiplied the effective strength of Thunderbolt units. An aircraft that might have been scrapped by other air forces could often be repaired and returned to combat within days. This maintenance efficiency meant that the numerical superiority of Thunderbolt units was even greater than production numbers suggested. While German units struggled with spare parts shortages and inadequate maintenance facilities, American Thunderbolt groups maintained high operational readiness rates throughout the war. The training pipeline for Thunderbolt pilots and ground crews represented another American advantage. Pilots received extensive training in the United States before being sent to operational units. This training included not just flying skills, but also technical knowledge about their aircraft systems. A P-47 pilot understood how his turbo-supercharger worked, how his guns were synchronized, and what his aircraft's limitations were. This knowledge made them more effective in combat and better able to exploit their aircraft's capabilities. Ground crews received equally thorough training. Mechanics were specialists in particular systems, engines, airframes, electrical systems, or armament. This specialization allowed them to maintain their particular systems to high standards. Armorers became experts in the complex ammunition feed systems of the 8.50 caliber guns, ensuring reliable operation in combat. The support infrastructure extended to technical documentation and field modifications. Republic Aviation published detailed technical manuals that allowed maintenance crews to understand and repair even complex systems. Field service representatives worked with operational units to implement modifications and address problems as they arose. This continuous feedback loop between combat units and manufacturers ensured that lessons learned in combat were rapidly incorporated into both production aircraft and field modifications. The combination of robust design, efficient manufacturing, thorough training, and excellent support made the P-47 one of the most effective weapon systems of the Second World War. It wasn't just a great aircraft, it was part of a comprehensive system that ensured it could be built in quantity, maintained in the field, and operated effectively in combat. This systematic approach to warfare gave the United States an advantage that Germany, despite its technical brilliance, could never match.
The P-47's combat record against specific German aircraft types reveals much about its capabilities and how tactics evolved to exploit them. Against the Messerschmitt Bf-109, particularly the G-series that dominated in 1943-44, the Thunderbolt held distinct advantages at higher altitudes. The Bf-109's liquid-cooled Daimler-Benz engine suffered significant power loss above 25,000 feet, while the P-47's turbo-supercharged Double Wasp maintained full power to 30,000 feet and remained effective even higher. This altitude advantage allowed Thunderbolt pilots to dictate the terms of engagement. They could climb above German formations and dive on them with overwhelming speed advantage. The Bf-109's light construction also made it vulnerable to the P-47's heavy machine guns. A short burst from 8.50 caliber weapons could tear a Bf-109 apart, while a German fighter's 20mm cannon, though powerful, had limited ammunition and required precise aiming. Against the Focke-Wulf FW-190, the matchup was more complex. The radial-engined FW-190 had better roll rate and low-altitude performance than the Thunderbolt, making it dangerous in turning engagements at lower altitudes. Early in the war, FW-190 pilots exploited these advantages effectively. However, as American pilots developed boom and zoom tactics and learned to keep their speed up, the balance shifted. The FW-190's BMW 801 engine, like the Bf-109's power plant, suffered at high altitude. Above 25,000 feet, the Thunderbolt's performance advantage became decisive. The FW-190 also proved vulnerable to the P-47's firepower. Its air-cooled radial engine, while less vulnerable to cooling system hits than liquid-cooled engines, could still be disabled by the concentrated fire of multiple .50 caliber weapons.
The introduction of the FW-190D, with its liquid-cooled Jumo 213 engine, addressed some of the high-altitude performance issues, but by this time, the numerical superiority of American fighters was overwhelming. Against twin-engine fighters like the Messerschmitt Bf-110 and Me-410, the Thunderbolt was devastating. These larger, less maneuverable aircraft stood little chance against the P-47's combination of speed, firepower, and protection. German heavy fighters, designed primarily as bomber-destroyers, lacked the agility to evade Thunderbolt attacks and the structural strength to withstand their firepower. The P-47's encounters with the Me-262 jet fighter represented the ultimate test of propeller-driven against jet technology. While the Me-262 was 100 miles per hour faster in level flight, the Thunderbolt could defeat it through superior dive acceleration, better maneuverability at combat speeds, and vastly superior firepower. The Me-262's engines were slow to spool up, making it vulnerable during takeoff and landing. Its light construction made it fragile. A few hits from .50 caliber weapons could cause catastrophic damage. The jet's high speed also made it difficult for its pilots to aim effectively, while Thunderbolt pilots could use their aircraft's stability to deliver accurate fire. Perhaps most importantly, the Me-262 was available in tiny numbers compared to the thousands of Thunderbolts. Even with its technological advantage, it couldn't change the outcome of the air war. The P-47's effectiveness against ground targets deserves particular examination. The aircraft's heavy construction allowed it to survive the light flak that was the primary defense of German ground forces. Its 8.50 caliber machine guns, when loaded with armor-piercing incendiary ammunition, could penetrate the top armor of all but the heaviest German tanks. Against softer targets like trucks, trains, and artillery positions, the effect was devastating. A 2-second burst from a Thunderbolt's guns delivered 160 half-inch projectiles into the target area. This volume of fire could destroy multiple vehicles in a single pass. The addition of rockets and bombs made the P-47 even more lethal. The 5-inch HVAR rockets could penetrate up to 4 inches of armor, making them effective against even heavy tanks when fired into their thinner side or rear armor. The 1,000-pound bombs carried by later variants could destroy bridges, bunkers, and other fortified positions. What made the P-47 particularly effective in the ground attack role was its ability to survive battle damage. German flatgunners quickly learned that shooting down a Thunderbolt required either a lucky hit or concentrated fire from multiple weapons. A P-47 could absorb hits from 20mm cannon shells and still return to base, while similar damage would destroy lighter fighter bombers. This durability allowed P-47 pilots to press their attacks home with determination that pilots of more fragile aircraft couldn't match. The psychological effect on German ground forces was profound. Knowing that the aircraft attacking them could likely survive their defensive fire undermined the morale of anti-aircraft crews. Tank crews, who feared little from most aircraft, developed a healthy respect for the Thunderbolt's ability to disable their vehicles with rocket and machine gun fire. The P-47's combat record against specific types of targets demonstrates its versatility. Against aircraft, it proved capable of engaging everything from nimble fighters to heavy bombers. Against ground targets, it could destroy everything from individual soldiers to fortified positions. This multi-role capability made it invaluable to the Allied war effort. While specialized aircraft might outperform it in specific missions, no other fighter could match its ability to perform so many different roles so effectively. This versatility came from its fundamental design philosophy. Alexander Kartveli and his team at Republic Aviation had created not just a fighter, but a weapons platform that could be adapted to multiple missions. The aircraft's robust construction, powerful engine, and heavy armament made it suitable for roles that its designers had never envisioned. This adaptability ensured that the P-47 remained relevant throughout the war, even as missions and requirements changed. The P-47's success against such a wide variety of opponents and in such diverse roles stands testament to one of the most successful aircraft designs in history. It proved that a well-designed aircraft, properly employed, could dominate in air-to-air combat while simultaneously becoming the most feared weapon on the battlefield.
The human element of the Thunderbolt story is as compelling as the technical achievements. The young men who flew these massive fighters came from every corner of America and every walk of life. They were farm boys from the Midwest, college students from the East Coast, factory workers from industrial cities, and everything in between. What united them was the challenge of mastering one of the most demanding fighter aircraft of the war. Initial training on the Thunderbolt was a shock for many pilots transitioning from smaller, lighter trainers. The P-47's size and weight made it handled differently from anything they had flown before. Takeoffs required careful attention to torque and P-factor. Landings demanded precise speed control. Too fast, and the aircraft would float down the runway. Too slow, and it would drop like a stone. The massive engine created significant gyroscopic precession that affected maneuvers. Yet those who persevered discovered that the Thunderbolt, for all its size, was an honest aircraft. It responded predictably to control inputs and had no vicious habits once its peculiarities were understood. The transition from training to combat was even more dramatic. New pilots arriving in England found themselves facing the most experienced air force in the world. The learning curve was steep and often fatal. Many Thunderbolt pilots didn't survive their first 5 missions. Those who did quickly learned that the aircraft's reputation for clumsiness was undeserved if one fought to its strengths rather than its weaknesses. The key was energy management. The P-47's weight, which made it sluggish in sustained turns, gave it tremendous energy retention in dives. Its powerful engine allowed it to convert speed back into altitude rapidly. Pilots learned to fight in the vertical plane, using diving attacks and zoom climbs to maintain energy advantage over more maneuverable opponents. They discovered that the Thunderbolt's roll rate, while not exceptional, was adequate for setting up deflection shots during high-speed passes. The 8.50 caliber guns required different aiming technique than the rifle caliber weapons many had trained with. The convergence pattern had to be set for the pilot's preferred engagement range, and sighting had to account for the different trajectories of the various ammunition types. But when everything came together, the effect was devastating. A well-aimed 2-second burst could destroy any aircraft in the sky. The confidence that came from flying such a well-armed and protected aircraft cannot be overstated. Thunderbolt pilots knew they could take hits that would destroy other fighters. They knew their firepower could end any engagement quickly. This confidence made them aggressive in combat, which in turn made them more effective. The relationship between pilots and their aircraft was often deeply personal. Many gave their Thunderbolts names and nose art. Crew chiefs took pride in keeping their aircraft in perfect condition. This personal investment paid dividends in combat, where well-maintained aircraft and motivated pilots performed better. The ground crews who maintained the Thunderbolts deserve equal recognition. Working in primitive conditions, often in mud and freezing weather, they kept the aircraft flying. The P-47's complexity made maintenance challenging. The turbo supercharger system required careful adjustment. The electrical systems that controlled the guns and other equipment needed constant attention. The massive double wasp engine, while reliable, demanded skilled maintenance to deliver its full performance. Armorers faced the back-breaking work of loading 3,400 rounds of ammunition for each mission, and then clearing and maintaining the 8 machine guns. Their work had to be perfect. A jammed gun could mean the difference between life and death for the pilot. The success of Thunderbolt units depended as much on these unsung maintainers as on the pilots who flew the missions. The evolution of tactics reflected the growing experience of Thunderbolt units. Early in the war, American pilots tried to fight like their German opponents, with disappointing results. As they gained experience, they developed methods that exploited their aircraft's advantages. The thatch-weave mutual support system allowed flights of Thunderbolts to protect each other. The Finger 4 formation provided good visibility and mutual support. But the most important development was the emphasis on energy fighting rather than turning combat. Thunderbolt leaders like Hub Zemke, Gabby Gabreski, and Bob Johnson developed and refined these tactics through hard experience. They learned when to engage and when to disengage, how to use altitude advantage, and how to coordinate their attacks. Their leadership transformed the Thunderbolt groups from inexperienced units into the most effective fighter forces in the European theater. The human cost of this learning process was high.
Many young pilots died before they could gain the experience needed to survive. But those who survived became some of the most effective fighter pilots of the war. Their stories, from Bob Johnson's miraculous return in his badly damaged aircraft to Gabby Gabreski's steady leadership, form an essential part of the Thunderbolt legend. The P-47 community developed its own culture and traditions. Pilots shared lessons learned, developed new tactics, and supported each other through the stress of combat. This camaraderie helped them endure the losses and continue the fight. The bond between pilots and their aircraft was often expressed in the names and nose art they applied. Hunt Hunter, Snafu, Big Stud, and hundreds of other personalized aircraft reflected the pride and affection their pilots felt for the massive fighters that protected them and brought them home. This human element, the skill, courage, and determination of the men who flew and maintained the Thunderbolts, was ultimately what made the aircraft so effective. The P-47 was a magnificent machine, but it took great men to unlock its full potential. Their story is an essential chapter in the history of aerial warfare.
The legacy of the P-47 Thunderbolt extends far beyond its wartime service. After World War II, many Thunderbolts continued serving in air forces around the world, including those of Brazil, Chile, Colombia, Ecuador, Mexico, Peru, Turkey, and Yugoslavia. Some saw combat in various regional conflicts well into the 1950s. The aircraft's rugged construction and simple maintenance requirements made it ideal for nations with limited technical infrastructure. In the United States, the Thunderbolt served with the Air National Guard until 1955, a testament to its durability and usefulness even in the jet age. The P-47's design philosophy influenced subsequent American aircraft development. The emphasis on survivability, firepower, and pilot protection became hallmarks of U.S. fighter design. The concept of a multi-role aircraft, capable of both air superiority and ground attack missions, foreshadowed modern fighters like the F-16 and F-35. The Thunderbolt's success demonstrated that effective warplanes needed to be more than just performance numbers on a specification sheet. They needed to be survivable, reliable, and capable of delivering decisive firepower. The aircraft's impact on manufacturing techniques was equally significant. Republic Aviation's production methods, particularly at the Evansville plant, set new standards for aircraft manufacturing efficiency. The lessons learned in building thousands of Thunderbolts informed subsequent military and civilian aircraft production. The quality control systems developed for P-47 production became industry standards. For the pilots who flew them, the Thunderbolt left a lasting impression. Many considered it the best fighter of the war, not for any single quality, but for its overall effectiveness and ability to bring them home safely. The aircraft's massive size, which initially seemed like a liability, became a virtue in their eyes. There was comfort in knowing they were protected by armor plate and surrounded by a structure that could absorb incredible punishment. The Thunderbolt's reputation among aviation enthusiasts remains strong today. Restored examples flying at air shows demonstrate the aircraft's impressive presence and distinctive sound. The sight and sound of a P-47 taking off or performing a low pass still captures the imagination, much as it did during the war. Museums around the world display Thunderbolts, with each aircraft having its own story to tell. Some, like the P-47D Hunt Hunter at the National Museum of the United States Air Force, are meticulously restored to their wartime condition. Others, recovered from crash sites, serve as memorials to the pilots who flew them. The aircraft's combat record has been the subject of extensive historical study. Analysts of gun camera footage, combat reports, and loss records have confirmed the Thunderbolt's effectiveness. The stories of individual aircraft and pilots continue to be discovered and documented, adding to our understanding of this remarkable aircraft's service. For historians, the P-47 represents an important case study in weapons development and employment. It demonstrates how an aircraft initially dismissed as inferior could, through proper tactics and incremental improvement, become one of the war's most effective weapons. The Thunderbolt story is one of adaptation, innovation, and ultimate triumph. Perhaps the most enduring legacy of the P-47 is what it represents about American industrial and military capability during World War II. The aircraft embodied American strengths: mass production, technical innovation, practical engineering, and the ability to learn and adapt quickly. It wasn't the most elegant aircraft, or the fastest, or the most maneuverable,
but it was exactly what was needed to win the war of attrition in the European skies. The Thunderbolt's success came from its ability to do everything well enough and some things exceptionally well. It could dogfight when necessary, escort bombers effectively, and devastate ground targets. It could survive damage that would destroy other aircraft. It could be produced in the thousands and maintained in difficult conditions. These qualities made it one of the most important aircraft of the Second World War. Today, when we see a P-47 Thunderbolt in a museum or flying at an air show, we're seeing more than just a historic aircraft. We're seeing a symbol of American industrial might, of the skill and courage of the men who flew and maintained it, and of the turning point in aerial warfare when quantity and quality merged to create overwhelming air power. The Thunderbolt story is the story of how the United States Army Air Forces learned to fight and win in the skies over Europe, and how a flying milk bottle became one of the most feared and respected aircraft of all time.
The operational statistics of the P-47 Thunderbolt tell a story of overwhelming effectiveness that few other aircraft of World War II can match. When examining the numbers, what emerges is a picture of an aircraft that not only survived the brutal learning curve of 1943, but went on to dominate the European Air War in 1944 and 1945. The scale of Thunderbolt operations is difficult to comprehend. Between April 1943 and May 1945, P-47 units flew over 500,000 combat sorties in the European theater alone. This represents an average of nearly 700 sorties per day for more than 2 years of continuous operations. The sortie rate peaked during critical campaigns like the Normandy invasion and the Battle of the Bulge, when Thunderbolt groups often flew multiple missions per day. The aircraft's reliability was extraordinary. Despite operating in harsh conditions from primitive forward airfields, mission abort rates due to mechanical failure rarely exceeded 5%. This reliability meant that when missions were planned, commanders could count on nearly every available Thunderbolt being airworthy. The maintenance hours per flight hour ratio of approximately 15:1 was excellent for a complex fighter aircraft, especially when compared to German types that often required 50 or more maintenance hours per flight hour by war's end. Combat losses tell their own story. Total P-47 losses in the European theater amounted to 1,723 aircraft from all causes, including accidents. This represents a loss rate of approximately 0.34% per sortie, an unremarkably low figure given the dangerous missions the aircraft flew. When compared to the claims made by Thunderbolt units, the loss-to-victory ratio becomes even more impressive. The official credit for aerial victories by P-47 units in Europe stands at 3,752 enemy aircraft destroyed in air-to-air combat. This gives the Thunderbolt a kill-to-loss ratio of better than 2:1 in aerial combat. When ground kills are included, the Thunderbolt's effectiveness becomes even more apparent. The documented destruction of 3,315 aircraft on the ground, plus the massive totals of ground vehicles and equipment, demonstrates the aircraft's versatility. No other fighter of the war achieved such balanced success in both air-to-air and air-to-ground roles. The ammunition expenditure statistics border on the incredible. 9th Air Force Thunderbolt units alone fired over 135 million rounds of .50 caliber ammunition during the war. This represents enough ammunition to fire continuously from all 8 guns of a P-47 for over 625 hours. The logistics required to supply this amount of ammunition, from manufacturing to transportation to frontline distribution, was a monumental achievement in itself. Bomb and rocket expenditure was equally impressive. The same 9th Air Force units dropped 120,000 tons of bombs and launched 60,000 rockets. This ordnance tonnage exceeds what many medium bomber forces delivered during the same period. The psychological impact of this firepower on German forces is impossible to quantify, but was undoubtedly significant. The cost-effectiveness of the Thunderbolt program is worth examining. At approximately $85,000 per aircraft in 1944 dollars, equivalent to about $1.2 million today, the P-47 was considerably less expensive than the B-17 bomber at $240,000, or even the P-51 Mustang at $95,000. Given the aircraft's multi-role capabilities and the damage it inflicted on German forces, the Thunderbolt may have been one of the most cost-effective weapon systems of the war. The human cost, while tragic, was lower than might be expected given the intensity of operations. Approximately 1,500 Thunderbolt pilots were killed in combat in the European theater.
While each loss was tragic, this number represents a lower loss rate than many other fighter types experienced. The aircraft's durability and the extensive training its pilots received undoubtedly contributed to this relatively favorable survival rate. The Thunderbolt's service in other theaters, while less documented than its European service, was equally impressive. In the Pacific, P-47 units claimed nearly 700 aerial victories against Japanese aircraft while suffering minimal losses. The aircraft's long-range capabilities in the P-47N variant made it ideal for the vast distances of the Pacific theater. In the Mediterranean and China-Burma-India theaters, Thunderbolts performed similar multi-role missions with great success. The post-war service life of many Thunderbolts demonstrated their inherent durability. Many aircraft accumulated over 1,000 flight hours during the war, and several served for another decade in various air forces. Some surplus P-47s were modified for civilian use as high-performance racers or spray aircraft, further testament to their robust construction. When all the statistics are considered, the sortie rates, the victory totals, the loss ratios, the ammunition expenditures, and the cost figures, what emerges is a clear picture of an aircraft that delivered exceptional value for the resources invested. The P-47 Thunderbolt was not just a successful fighter, it was one of the most effective weapon systems in terms of both combat performance and cost-effectiveness of the Second World War. The numbers tell a story of an aircraft that started as an object of mockery, but ended as a war-winning weapon that dominated every aspect of aerial warfare it was assigned to.
The final chapter in the P-47 Thunderbolt's story is one of enduring legacy and historical significance. More than 75 years after the last Thunderbolts were retired from military service, the aircraft continues to capture the imagination of aviation enthusiasts, historians, and veterans alike. The aircraft's place in history is secure, not just because of its combat record, but because of what it represented about American industrial power and military innovation. For the nations that used it, the Thunderbolt became a symbol of air power and technological achievement. In the United States, it represented the triumph of American engineering and production capability. For the Allied nations that flew it, it symbolized the material superiority that ultimately overwhelmed the Axis powers. Even for Germany, the aircraft came to represent the unstoppable nature of American industrial might. The stories of individual Thunderbolts and their pilots continue to be discovered and preserved. Aircraft recovered from crash sites are carefully restored, often to flying condition. Each recovery adds another piece to the historical record, helping us better understand the aircraft's service and the men who flew it. The surviving Thunderbolts that grace museums around the world serve as tangible connections to this important chapter in aviation history. The aircraft's design influence can be seen in subsequent American fighters. The emphasis on pilot protection, survivability, and heavy firepower became hallmarks of U.S. fighter design philosophy. The concept of a multi-role aircraft that could perform both air superiority and ground attack missions effectively foreshadowed modern combat aircraft. Even the Thunderbolt's massive size and powerful engine set a pattern for American fighters that would continue through the jet age. For the men who flew and maintained the Thunderbolts, the aircraft left a lasting impression. Veterans reunions and oral history projects have preserved their stories, ensuring that the human experience of flying this remarkable aircraft won't be forgotten. Their accounts provide invaluable insights into what it was like to take the massive fighter into combat, to depend on its rugged construction for survival, and to wield its devastating firepower against the enemy. The Thunderbolt's impact on aerial warfare doctrine was profound. The tactics developed by P-47 units, particularly the emphasis on energy fighting and the development of effective ground attack techniques, influenced U.S. Air Force doctrine for decades. The lessons learned about coordinating fighter operations with strategic bombing campaigns and ground forces informed military planning throughout the Cold War and beyond. In popular culture, the P-47 has maintained a presence that few other World War II aircraft can match. From appearances in films and documentaries to scale models and video games, the Thunderbolt continues to be recognized as one of the iconic aircraft of the war. Its distinctive appearance, the massive elliptical wings, the deep fuselage, the four-bladed propeller, makes it instantly recognizable to aviation enthusiasts of all ages.
The historical assessment of the Thunderbolt has evolved over time. Early post-war accounts often favored more glamorous aircraft like the P-51 Mustang, but as historians gained access to more complete records and conducted deeper analysis, the P-47's contributions have been properly recognized. Modern historical assessment places the Thunderbolt among the most important and effective fighter aircraft of World War II, particularly when considering its performance across all mission types rather than in any single category. The aircraft's service with other nations after the war adds another dimension to its story. In South American air forces, the Thunderbolt saw combat in various conflicts and revolutions. Its ruggedness and simplicity made it ideal for nations with limited maintenance infrastructure. Some of these aircraft survived into the 1960s, a testament to the soundness of the original design. Today, approximately 30 P-47 Thunderbolts survive in museums around the world, with about a dozen in airworthy condition. These aircraft, when they fly, provide a living connection to the past. The sound of the double Wasp engine, the sight of the massive fighter in the air, the smell of oil and exhaust, these sensory experiences help new generations understand what it was like when the Thunderbolt ruled the skies. The P-47 Thunderbolt's story is ultimately one of transformation. It began as an aircraft mocked by its enemies and doubted by its allies. Through the skill and courage of the men who flew it, the dedication of those who maintained it, and the relentless improvement of its design, it became one of the most feared and respected aircraft of World War II.